Jai Hind everyone. I Neeraj Sharma, Assistant Professor EC Department at Ajay Kumar Garg Engineering College, Ghaziabad. I am before you to present the video lecture for the subject Microwave and Radar Engineering, and which code from as per the AKG syllabus, that is the KEC 074. So in the continuation of the complex topic series, I have selected the topic from the unit 3, that is the traveling wave tube amplifier. This one. Also, it is abbreviated form. It is used as an TWT. Okay. So unit 3 basically, as per the, before going into the detail for this topic, just I want to say something regarding this introductory part. This basically, this unit will relate to the, as per the microwave source for the any microwave test bench or the generation of any microwave signal. So in that series, we are using the klystron tube as a microwave source, and as well as klystron tube also have an with its specific families, like it will having the what we can say klystron tube having the different types classification, like 2-cavity klystron amplifier, okay, multi-cavity klystron amplifier, reflex klystron amplifier. Okay, but all these in this category, all these are just related to the category of cavity. Here the basic principle of signal amplification, that is the cavity. First of all, the cavity is responsible for to the generation of the microwave signal. So in which the microwave signal actually cavity electron coming from the any electron gun, and the gap between the cavity, they interact with the RF field, and after interaction with this RF field, they will be now create velocity modulation will exist or generate into the test in the klystron tube, and after that, after bunching of these, velocity modulation will responsible for the bunching of electron, and after that the electron will amplify the RF signal. So the main concept in that, the cavity means the cavity gap is responsible for the generation of the microwave or the amplification of the microwave signal. But there are two categories in this, if we will see. So the first one is based on the cavity, and another one, that is the linear beam category, in which we are using the beam category. In linear beam category, we are using this TWT amplifier, BWO backward wave oscillator, and also we can use the what we can say the next one, that is the BWO and the magnetron. This is also the devices that is used for the generation of the microwave signal. So all of these I have chosen the topic traveling wave tube amplifier, TWT. So this TWT is different from the, in the category of linear beam, it is different from the klystron family. So for that, starting, this is a TWT, traveling wave tube amplifier, that is abbreviated as the TWT. So here in this introductory part, in TWT microwave, first one, this is the non-resonant circuit. That means the wave propagates inside the with the same speed as the electron beam generate from the or emit from the what we can say from the electron gun. Next one of the different thing or the main important structure that can be used for this traveling wave tube for the amplification of the microwave signal, that is the our slow wave structure. So this TWT amplifier will using this slow wave structure. This one is the one important point in the working of this slow TWT amplifier. So what will happen when any field electron is interact with this helical structure, which is also a part of this slow wave structure technology methodology. So it will slow down the phase velocity of wave. So before this one, TWT main basic principle is this: using the slow wave structure is responsible for the amplification. But how it is differ from the klystron, two cavity klystron tube. So because this is also one important, before moving into the detail with this TWT, this one is also an important thing here, that why we are approaching to this TWTs, although we have the klystron family like two cavity klystron. So for the main basic difference on all these two devices, that is the instrument, that the interaction of electrons, in which as earlier I told that the interaction of electrons with the RF field is not continuous, means it is only interacted when the wave, the electron will enter into the cavities gap, and at the time of cavity gap where we are applying the RF input signal, and it will get the interaction with the electron. So the electron's speed will be increase or decrease, or it will be the remain same as per the condition what the waveform we are going to apply. But so the interaction is up to the limited duration there. Okay, but if we discuss about the traveling wave tube, we will see here in the next slide, we will see that how the interaction of this electron beam is continuous throughout the length of the traveling wave tube. So how it will continuously interact, we will take place. So that means, it means the wave is propagating continuously in the TWT, but whereas in the klystron it is not continuous. So the buncher will create in the cavity resonator. So these are some important points where it will make the difference between the TWT and the two klystron amplifier. The major one is that the interaction of electrons is continuous in the TWT, but it will not continuous in the two cavity klystron. So the main principle that we are going to use for this TWT amplifier, that is the slow wave structure, which I already emphasize here. So what is this? So first of all, now we will see this one, a slow wave structure. So there are the four different categories, for the slow wave structure that we can use. That is the first one, that is the helical line structure. Either we will use like this one, either you can use folded back line, zigzag path line, interdigital line, and as well as the corrugated waveguide. So these are the some possible structure that can be used to slow wave the propagation of wave in the TWT amplifier. So out of these we can use any one, but in the TWT amplifier we are using this helical line structure, helical tube we are using here. So these are the this is the special circuits that are used in microwave tube to reduce the velocity in certain directions, so the electron beam and signal can interact effectively. So that means it will create the long path basically mainly. So that's why the wave will slow down in this structure, and the bunching will take the bunching duration will become high, and as well as the length will increase. So there are various structure available, as you can see in this all pictures you can see here. So out of these, but the helical structure is most popular here, so that we can use for the slow wave structure to generate the or amplify the signal in the microwave test bench. Okay, now after that it provides the how it will provide the slow wave, because it provides the longer path length for the EM transmission. That means when the wave will propagate inside this like this one, so electron will moving, so they like this geometry trajectory they will follow like this one. So that's why it will become the path length will be increased. So this is the slow wave structure, and we are using, later on we will see how the structure will how the length will increase in this. So as per the slow wave structure, we are using this helical path. So this is the geometry of this helical structure. So here you can, the gap between the two turns, that is defined by pitch, and the velocity. For that point of view, we can use here the P is the helix pitch, D will be the diameter, and Xi will be the pitch angle. So in the most of the time exam will, the question will be asked on to the basis of the calculate the phase velocity. So for that point of view, we are using the formula phase velocity is equals to C velocity of light into P upon pi d, where P is the helix and d is the diameter of helix. So this will be the answer will comes out as per this geometry, how it will coming out. So for that this relation now you can see Vp by C is equals to P upon this one P upon under root of P square plus pi d square, and how it will comes out. So geometry you can see in this figure B here. So this is the its numerical analysis point of view. What should be the phase velocity if we have the pitch length and the diameter if we have with us. So we can also calculate the phase velocity. Number of times the numerical problems has been asked in the exam from this relation. Now after that we will moving toward the working mechanism of this TWT. So the structure that you can see here, this one is the structure for the TWT, traveling wave tube amplifier. So it will having this part, having the electron gun assembly where this heater supply, cathode, control anode, and here we are using the tube body, and we are also providing this one part and this one part as an electron beam, focusing magnets. Here the helix structure we are using. At the end of the helix we can using here this one pole like as an attenuator, these component as an attenuator. Here we are providing this RF input at the helix initially part, RF supply we are providing here. After that now we are providing the helix structure, then the RF output and the electron beam at the collector end. Here you can see here. So this will be the complete method mechanism. For to understand the mechanism, this will be the structure for the traveling wave tube amplifier. So how it will work, let we see when we will see. So as per the simplification, just let's see, consider the electron gun and the helix structure there, and after that the collector part. So in spite of considering all these, but they have also having their different their working model with them, so that's why they can work. But for simplification, just we are considering this electron gun part and this gun part and this one helix structure as well as this collector part. So what will happen when we are any electron beam is passing through, when any electron beam is passing through this helix, electron beam is now generated from this electron gun and electrons are now emitting from here like this one. So focusing electrode will now giving the alignment or send all the electron toward the helix. So that's why they cannot be not to come out from these ends. After that, when this electron coming out from this electron gun, let's say 3 electrons are now coming like this one. 3 electrons, let's say we are considering as per the our cycle. Let's say waves we are now providing here. This one is the positive part, this one is the negative part, and this is the reference part. So in this, when the positive part will come, so at this time electron coming from for this duration, and at this time when they will interact come into this helix structure, so what will happen, and here we are providing the electric field, and after that electric field we are providing, and this polarity force will, then this electron will interact with the RF input, that means the electric field of this RF signal. So what will happen, this will electron having the negative charge and this one is having the positive terminal. So that's why the deaccelerating force will be applied onto this, like with the relation of F is equals to minus of E into capital E. So with this, the structure, with this concept, for this positive cycle, what will happen, a deaccelerating force will be applied onto this electron, and so that's why this interaction will take place and the velocity will now change. So after that, what will happen, velocity will decrease, means at the speed by which this electrons will moving, this electron will traveling towards in the helix, its speed will reduce. Let's say now it will now reaching here somewhere. So, and also there is some gap between all these free electrons corresponding to this positive cycle, this reference as well as the negative. When this negative reference cycle electrons will come, and this at this time this will interact with this field, so there is no velocity change in this. So velocity will unchanged at this time, and it will traveling to this helix structure as per their as usual speed. So after that, what will happen? It will now its speeds it will come first one, its speed will reduce, and when it will come, its speed will be the same, but it is coming after some interval. So that's why the gap will now reduce. Let's say gap will now reduce. Okay. After that, when this next one last electrons, let's say for this negative cycle, when it will interact come into the helix structure, and it will interact with this RF input signal, which is now applied here already. So they have the same polarity, negative, electron have the negative, and it will also have negative charge. So that's why they will apply the accelerating force onto the field, will affected by the feel the accelerating force. So that's why its speed now will become increased. Its speed will become faster. So that's why it will come at some places it will now come like this. So the major point that has to note here is that the velocity modulation, that means the reduction, increase or decrease in velocity of electrons. So that's why velocity modulation will take place, and the gap is now reducing into the electrons after certain interval of time. Here the attenuators are there, so that's why they can, if any signal is coming out from this helix structure, electrons will comes out, they will now attenuate it. So after that, when they continuously move with the same theory at some interval, these electrons are now merged together. So that's why, because as per the change in the because of this velocity modulation, as per the velocity modulation, what will happen? This speed will increase or decrease. So that's why the main effect come into the spacing between the electrons. It will reduce at the end of this helix structure. They are now, all electrons are now merged, and they create the bunch, and this cycle will repeat a number of times, and these bunches are collecting together at the end, and they will give their energy to the electron, give energy to the RF signal. So the RF signal will amplify at the output. So here we can get the output form. That means if we are applying this signal at the output end, we are now providing the amplified signal like this one. Okay, so this is the main working principle of this TWT amplifier, how it will work. So in this, here you can see that the same what I have discussed. So I have now write down here all these things. So the first one, that it consists of an electron gun which produces an electron beam, first one. Then the surrounding permanent magnet along the axis of tube is used to focus the electron into the focused beam. So that's why this will now moving only this path, not to they cannot come out from this structure outside. After that, helical slow wave structure is placed. This one now is placed here. After applying the applied RF signal, propagates around the turns of the helix and produces an electric field at the center of the helix direct along the helical axis. After that, the axial phase velocity of the electric field travels with the velocity equal to the velocity of electron beam. After that, now at the center of helix, there is an attenuator which is placed to attenuate the reflected wave due to the mismatch if happened. So precautionary we are taking this one. Electron injected by electron gun travels with the uniform velocity up to the entry of the helix structure. That means like this one, initially what we are now considered here, electron. Before entering here, the speed will same. But after entering this structure, the interaction will take place, and after entering the helix structure, interaction takes place between the axial electric field and the moving electron. So interaction will takes place. That means their velocity will be changed. Either it will be increased or it will be decreased. So that means ultimately what will happen? The velocity modulation will take place in this structure. So this is the this velocity modulation is responsible for the bunching of electrons, and after bunching the signal will be now amplified at the output. So those electrons which is enter the helix at zero, not affected by the signal wave, what I have discussed already, those electrons entering when electric field is directed against the electron flow are accelerated, that means for this one, and those electrons when electric field directed along the electron flow are de-accelerated, this means for the opposite polarity. So here at this time speed will decrease, and at this time polarity will be the same, so it will be now accelerating. So because of all these interaction, the velocity modulation electron bunching takes place. This electron bunching is responsible for the amplification point of view or amplification purpose. So in this structure that you can see here, this figure will also explain the same thing what I have discussed. So this bunches will give their kinetic energy to the electric field present in the in RF interaction region to the next cycle, and the amplification of RF will take place. So after that, so this amplified RF signal will produce denser bunches of electrons. Number of electrons are in for the next cycle. It will now again amplified, as you can see, it is the first one. This is now amplified, again amplified it. So that means as per the cycle, electrons will are continuously collecting for first cycle. Some little bit amount will be increased, amplification take place. Again for next cycle, they are merged with the next bunch will merge with the already bunched electron, again amplified signal. So in this way continuously signal will be amplifying. So and those denser bunches of electrons will further amplify the RF signal, and the RF signal is continuously amplified. So and this the RF signal is amplified till the attenuator. So that means if someone is coming, any mismatching will there, so that part will be now attenuated from the, so and at the attenuator the RF signal is attenuated, and after that the same process of bunching and transfer of kinetic energy from electron to RF signal will take place, like as what I have told as per the working methodology. And this is the how RF signal is structure. Signal is in helical structure is now amplified. So for that point of view, I have already discussed this working methodology. I have explained with this theory, the velocity modulation will take place, and the modulation will take place, and the bunches will create. So the RF field now becomes amplified. Okay. So this is now regarding this. So how this slow wave structure, helical structure will create the slow down the wave. So for that point of view, let's say I have just drawing this. Sorry. Let's say I am just creating this any helical structure here like this one. Okay. Now after that, I am just drawing some trajectory here. Let's say the trajectory of signal will be now amplified, like the for positive part. This one is for now the negative part. This one, as you can see now. Let's say the electrons are like this one. I have just taking some configuration here. So what will happen at some particular, when the field will come into the interaction of this RF field, let's say here this one, the gap is also matter between the two electrons. So when this entering like this one, same for this negative. After that, what will happen? They will now moving towards come into the interaction, their field will be decreased. So the spacing now little bit reduce like this one, and here at the particular interval all electrons are now combined together here, this one. Same for this, if you see this one part, same will be happened here. The spacing, this part, spacing between two electrons will now reducing. So here again So here the bunches will now take place and they are also bunched together. So when we will draw this trajectory path, if we will see in this, if you can see here, no. When we will draw the trajectory length considering, so actual length is now looking like this one, but due to the sinusoidal structure, the trajectory is now what like this. So the overall length duration will now increase. So because of this path length will now, what will happen here? It will now increase in this helical structure. So due to increasing of this RF length path of RF signal of electrons interaction in the with the RF field in the helical structure, so the path length will increase. So it will slow down the wave propagation. So that's why, because of increasing of this path length, the helical structure will be act as a slow wave structure here. So why we are using, this is the main method concept regarding this slow wave structure in the helical tube here. So as you can see with this geometry now here. So this is the now after that, what are the specifications for this helical structure? If you see, so for that point of view, this is the specification. Frequency range is from 1 to 100 gigahertz. Gain it will provide up to 60 dB. It will also use as a wideband amplifier. Low noise figure will be less than 10 dB and efficiency is 20 to 40%. So this is a specific TWT, and also the applications of these TWT here, that is the low noise RF amplifier for broadband microwave receiver. Due to long life, TWT also used as a power amplifier. These are the uses. And for medium and power and high power satellite transponder outputs, we are using for military application, phased array radar. In phased array radar, we are also using this TWT, and TWC is also used in the electronic counter measure system like ECM. So these are the some few application of this TWT amplifier. So this is now from my side regarding this topic, traveling wave tube amplifier TWT, and the reference that I have considered taken from the book SY Microwave and Devices and Circuits by SY Liao. So thank you and Jai Hind.